Hello, and welcome to Reill's tutorial. Today's topic will be discussing kinematics, and the subtopic will be qualitative graphing. Please like, share, comment, and subscribe to my YouTube channel. Okay, join with me and let's dive in. In our previous videos, we've been studying on kinematics, and now our subtopic today will be qualitative graphing. I know you'll be wondering what's qualitative graphing. So beyond all these mathematics calculations, the theoretical part, a clear way to define speed, acceleration, velocity is through graph. So this subtopic will be emphasizing on how to identify the speed, acceleration, and velocity on a graph. And we'll be looking at the position time graph, the velocity time graph, all those basic graphs, and are able to compare between two graphs so that once those graphs have been displayed, you'll be able to differentiate them accordingly. So let's see what we have for those for the graphing. The first one we're looking at is this graph. Either of these two graphs, it represents something that is not moving. So when we see a graph like this, then we know this graph has no change in position, the velocity is 0, and the acceleration is 0. No change in the position is because at this position here, it starts from this position, that it maintained the position to the end of the time. And when we have no change in position, there's no change in position, the position is just the same thing. Even if it keeps moving, but there's no change in position. So most likely we can look at this as the speed. It just keeps staying in the same position and move on that wave path, but no change in the velocity at all. A keynote, a straight line, no change in velocity, then no change in acceleration. If you see this one, just know it's a no change in position. This is a position versus speed we're looking at. Okay, let's look at the next one. In this case, either of the following two graphs represent an object moving at a constant velocity in the positive direction. Now this object is moving at a constant velocity in the positive direction. Because the object starts from here, this is the beginning of the position, then now it just keep moving, then it travels up in this direction. So the change position has changed. Let's assume this is 1, 2, 3, and 4. Similar here, 1, 2, 3, and 4. So the position started from 0, then I keep moving up. So when we see a graph like this, going up in this direction, we know there's a positive change in position because there's an increase in the position's number. The velocity is constant, at constant velocity, but the acceleration is 0. So looking at this other part now, here, the position is here, there's a change in the position, but the velocity is constant, at constant velocity. And you have this double line here, and it's as constant, double straight line, you know it's constant velocity and positive direction. Okay. And on we have, in this line, it's still a change in position. However, the position is in a negative, the position is changed negatively. So either of the following two graphs represent an object moving at a constant velocity in the negative direction. So the object started from here, the position started from there, but it has moved down to the negative position. So it is decelerating in the position, but the velocity is constant, but the acceleration is 0. So the velocity time graph is constant in this form here, is constant, but there's no acceleration. When we see this graph, okay, negative position, constant velocity, but no acceleration. Because remember, once the velocity is constant, there is no acceleration, because acceleration has to do with change in velocity, and velocity has to do with change in displacement. And displacement is position. So that's the change. So now we are having a change in position. So now we have a displacement. So the change in displacement is being defined here, but its velocity is constant. And that's now we have 0 acceleration because the velocity is constant. Okay. Next one. Now looking at this next one says, looking at this graph now, the position is changing a very different line. It's no longer straight, it's just in a different curve. So looking at this curve, we're seeing that the velocity has changed. It's not longer a straight drive, it's a curvy drive. The position started from line 0, and the velocity just keeps changing with time. The displacement keeps changing with time. This is a timeline, this is a position line. So here we started from this part, it kept moving, then it kept changing. It's not just constant, it is not on a straight path, but it goes up to the position level. So that's why it's positive. So right now we have a change in position, positive change in position because it's going positive towards the positive direction. Increasing velocity, so that means a change in velocity, but the velocity is increasing because it goes up this way. Because remember, velocity is change in displacement over change in time. So if the displacement is increasing, if the final displacement is more than the initial displacement, if d2 as the final displacement minus d1 is greater, then t2 minus t1 is also will give us a greater value. So let's assume d2 here is 5, and d1 is 0 over, then t2 is, let's say, 2, and t1 is 0. This will give us both positive value, that will be 3 over 2. So in a nutshell, it's an increase in the velocity because it's going up. As it's a change in the velocity, so we now have a positive acceleration, because since there's a change in velocity, that means it's also an acceleration going up, right? Okay, because the velocity the position is moving up in positive direction, so everything stays positive. And also, if you look at the other graph, it starts from this part, change in velocity, there was a change in velocity, so that's why it's going up in this line. This line graph is what? Position against time versus time, and this line graph is velocity versus time. So if there's an increase in position against time, there's also be a increase in velocity against time. So you want to pay attention to this graph. Okay, and let's keep moving. Then this next part, we have a positive change in position and decreasing positive velocity and negative acceleration. So either of the following two graphs represent an object slowing down in the positive direction. So what this entails is the position started at 0 and kept on moving good, but when it got here to this line, there was not much change in position anymore, or probably was descending, but at a particular timeline. So this is how this has been moved. And this positive change in position also indicates that it's on the positive side of the graph. Or here, in as much it decreases, there's a change in the position, it still stays on the positive side of the graph. However, in as much as it's still on the positive side of the graph, the change in this position that occurs this way also causes a decrease in positive velocity. So instead of the velocity going up like the previous graph, there was a little bit of decrease in that. So that means if this initial velocity started at a very higher speed, the final velocity started at a lower speed. That's the difference. And in that case, the acceleration will also be negative, because like what we did before, if the velocity stayed at 5, if d1 was at 5, right, then d2 and d2 is now 3. So for us to get this acceleration will be 3 minus 5. And let's assume the time graph to the time of b5, t1, 0, and t2, let's assume that was at time 5. So if this is 3 and this is 5, divide by the time of 5 minus 0, so that will be 2/5. So this has given us a decrease in value, right? This is a decrease in acceleration. 2/5, the decrease in acceleration. 2/5 is going to be equal to 0.4 meters per second square. That's the decrease in acceleration compared to the previous one. If the speed was set at, if the displacement was at 3 and it finalized at 5, so this would be an increase. It would be 5. So negative. This is negative 3. This is negative value. Negative 0.4 meters per second, because there's a negative change in the acceleration. Now the next graph is this. Looking at the position versus time and velocity at the time, we see that the line is driving down in different direction. And this is called a negative change in position. Apparently because the position started from the highest point here, then is decelerating down this way. So there's a negative change in position. Then the descending magnitude of negative velocity. There's a descending, and it is descending. However, there's a positive acceleration because there's a change in acceleration in velocity. So now there's a positive acceleration. So looking at this point, this velocity time graph, the size from this point here on the velocity time graph, then it goes all the way up here. So there's a change, is a positive change in acceleration, and it is decreasing negative velocity and a negative position. So there's a negative change in position, negative change in position, negative change in velocity, but positive acceleration. But if you remember the previous one, we had a positive change in velocity, decelerating positive velocity and we have negative acceleration. But this one now with this time graph, it's negative change in position because of the position start from here, but it's negatively changing because it's decreasing. Then it has a decreasing magnitude of negative acceleration. Decreasing magnitude because the magnitude is already decreasing. The value, the numbers are decreasing of negative velocity. What is a positive acceleration? So when we see this graph, we'll be able to define that. All right, one. This next graph says, looking at the graph, it's either of the two graphs represents an object speeding up in the negative direction. So this, when you see a graph like this, the object is speeding up in a negative direction. So now the object started from here, and this and change in position is negative because we started from this part up to 0. So it went down this way, right? So there's an increase magnitude of negative velocity. The velocity is increasing higher. There's an increase in the magnitude because of the curve is going like this. The previous one, the curve goes the other way. It goes in the previous graph, the curve goes like this. So there's a decrease, but this one is an increase, right? There's an increase in magnitude of negative velocity. There's an increase in that. Then there's also a negative acceleration. The acceleration is negative because when you have driving at a very high speed here, then you start reducing your speed, it goes down that way. And the same thing occurs to the velocity time graph. The velocity starts from here but falls on the negative side, so there's a deceleration in the acceleration on towards negative part here. So this one just explains probably running. When you start running, you start from a point and you run, and you keep running at a very high speed, then suddenly you start reducing your speed of running. You're anymore, we're just going down, but it's a negative velocity, but it's an increasing magnitude. And also your acceleration is stopping, it's decelerating. I know negative acceleration means it kind of also means deceleration because it's actually reducing your speed. You're dropping your velocity, dropping velocity. So that's what this line graph means. So let's try not to differentiate and make mistakes in any of those two, any of the graphs we've talked about today. Familiarize yourself with these graphs so that you can quickly look at any graph and have the same position, velocity, acceleration. So when you look at the graph, you'll be able to identify what's going on with either of the change in position, velocity, and acceleration, because this graph kind of defines them all. So with all of these that we've done today, let's look at an example. This example, graphing, qualitative graphing. This example says the velocity of a object as a function of time is given by the following graph, by this graph. At what point A, B, C, D, or E is the magnitude of the acceleration the greatest? At what point A, B, C, D, or E acceleration the greatest? Now let's analyze this. Let's look at A. The A starts at this point and it's just the beginning, so it's just moving on, right? So it started at this point here, then move to this part. So I will not say A has accelerated so much. Then let's look at D. Let's look at B. From A, it moves up to B. So there's a little change in changing the speed, changing the velocity. So the acceleration has increased a bit, but not that much. Then from B to C, the lap from B to C, there's so much changes. It has moved so much, and B keep driving up. It started from this drive and moved all the way. So there's much acceleration on the C side. Then in D part, once we got here, there's a line of change of reduced acceleration on the D, then it goes down at the E. So looking at this full graph, would say A and D, the slope in A and D is 0 because there's no change in slope. The slope in A and D is 0, whereby for B and E, B has a small positive slope, curve is a little bit small, then E has a negative slope change. But for C has the greatest acceleration. So in this graph, C has the greatest magnitude of acceleration so far. So that's what explains this line graph. So we have to, if you remember, we have to pay attention to all this detail. So when there's no change in position, we know the graph to look at. When there's a little change in their velocity, we know the graph to look at. When there's a high change in the acceleration, an increase in acceleration, when we see the graph, we should understand it. And when there's a reduction in this velocity. I hope this okay. Let me know if you have any question. You can put your questions on the comment section and I'll be happy to respond to those questions. This is the end of today's video. Please like, share, comment, and subscribe to my YouTube channel. I will see you in the next video. Thank you.